Hello everyone. So today we are going to learn about stereochemical aspects of addition reactions. So this reaction we have learned in our 11th standard. We are going to take an alkyne, and this alkyne is going to be subjected to partial reduction. Two reagents are going to be used, two pathways. One is through Lindlar's catalyst, which we have learned. Lindlar's catalyst, right? If I subject it to Lindlar's catalyst for hydrogenation, I get cis alkane, right? Cis alkene. Whereas the same alkyne is subjected to Birch reduction. This reagent is Birch reduction, we all know this, and I will get trans alkane. But when we subject a cis alkene, when I subject the cis alkene to with a Lindlar's catalyst, right? I am about to get an alkane, and addition reactions will happen. Then the addition reaction is found to be on the same side, and I get a meso compound. This is the meso compound what I got. If I subject the same compound, cis alkane with Birch reduction, I got a racemic mixture of D and L, both I get. So racemic mixture is what I obtain. Now, what is the stereochemical aspects of this addition reaction? That's what we are going to. Here I have taken again a cis compound. Okay, it's an cis alkene, and I am going to subject it with a sulfurous acid or Carrow's acid, right? Carrow's acid, and when I subject this to Carrow's acid, I get a racemic mixture, right? Racemic mixture. I will understand that these OH groups are added opposite to each other. Anti-addition would have happened. Whereas the same compound is subjected with osmium tetroxide in the presence of sodium hydrogen sulfate, then syn addition would have happened. So I get meso product. Now to understand this, we need to understand the nature of the compound. Nature means we need to understand whether the compound is cis or trans. Then we need to have an idea about the reagent also. What kind of addition it can make, what kind of addition it will affect. That is also we need to know. So for example, I have discussed some 4 cases over here, which is sufficient to predict the type of the stereochemistry of the products, right? So when we take a cis compound and addition happens by syn addition, then we are about to get meso compound. Whereas a cis compound is subjected to anti-addition, we will get racemic mixture. And when we take a trans compound and subjected to syn addition, we will get racemic mixture. Then trans compound subjected to anti-addition will give me meso compound. So we can understand one important thing. If both are on the same side, if cis means on the same side and syn is also on the same side, if both are same, then I will get meso. See here, anti, trans means opposite to each other, and addition also is also on the same side, opposite side. So if both are opposite, then I will get meso. If both are different, compound, the nature of the compound and the type of reagent, if they are different, then I am about to get a racemic mixture. So if we know the nature of the reagents or nature of the addition caused by the reagents, it is sufficient, and we can able to predict the stereochemistry of the product. To help you, I am going to discuss about 2 kinds of addition. One is hydrogenation and dihydroxylation. So for hydrogenation reaction, only 2 reagents can be used. The first one is Lindlar's reagent, as we discussed earlier. It will always cause syn addition, whereas the Birch reagent, Birch reduction, will always cause. During dihydroxylation, I can use potassium permanganate in the presence of cold dilute alkali solution, and it will always cause syn addition. Okay, and when we take osmium tetroxide in any form, osmium tetroxide in the presence of sodium hydrogen sulfate or hydrogen peroxide, whatever, and it will again cause syn addition only. Whereas paracids like Carrow's acids, H2SO5, and phenyl, this one, and HCOOH, any of these acids if I take, and it will always cause anti-addition. Selenium oxide in the presence of hydrogen peroxide will also cause anti-addition. And MMP MMPP in the presence of ethanol. MMPP stands for magnesium monoperoxythalate, and in the presence of ethanol it will also cause anti-addition. So if you can remember the kind of addition that are going to cause by these reagents, it is easier for us to predict the stereochemistry of the reaction, because such questions have been asked frequently.